All right, so now let's look into solving this problem. So first of all, let's look at set A. So set A is basically m consecutive numbers. Remember, consecutive numbers are a special form of arithmetic series, arithmetic progression with a common difference of 1. And so what we're gonna do now is we're gonna say that, okay, the sums to equal to 2m. And then B is a set where we have 2m consecutive and sum is equal to m. So remember that one thing we were talking about is the first, so we can write this, the sum as n over 2 times the sum of the first and the last term. But this is also basically equivalent to saying that it's like the middle term almost. So it's like if n is, or sorry, if n is even, then this, okay, so if n is even, then these are the average of, I guess, the middle two terms. And if n is odd, then so it's like this portion, I mean, is the middle term. So now what we have from here, like this relation, is that the middle term, so this is m consecutive integers. We're gonna assume that, okay, so we have that, so let's assume that m is even. In that case, then the sum of middle two terms, is equal to so s over n, and that's equal to 2m over m, which is 2. But unfortunately, there aren't any consecutive integers that sum to 2, so this is wrong. So that means m is probably odd, and the middle term is equal to 2. And for this one, 2m is obviously even, so the middle two terms sum to, our middle two terms have an average of 0.5. And obviously the two numbers that have an average of 0.5 and that are consecutive are 0 and 1. So our middle two terms are 0 and 1. Okay, so now, due to lack of space, I'm just going to erase this. But okay, so now we have this. One thing we know from here is that the largest number of A and, or sorry, is equal to the largest of B minus 99. And the reason is because if you think about it, B has, or if you think about it, this is like the middle term, and this is a 1. So, and you have m numbers, or m minus 1 numbers after this, and m minus 1 numbers before it. So it's definitely going to be like, so A to m is going to be larger than this one where there's m minus 1 over 2 terms after it, and then m minus 1 over 2 terms before it. And so this is going to be am. Yeah, I'm going to call this B. Okay. So now what this gives us is that definitely the largest value of the B sequence is greater than the largest value of A. So now all we have to find is the values of these in terms of m, and then we're good. And so how do you go about doing this? Well, these are consecutive numbers. So obviously the common difference is 1. And so the largest value of A would go from the middle term, and then you'd add m minus 1 plus over 2 because there's that many terms left over, because it's m consecutive numbers in the A sequence, right? So it's like A plus 1, A plus 2, so on and so forth. And then we have 2 somewhere in the middle, and then we have m plus 1 over 2, so on and so forth, till am. So that's how our sequence looks for A. So we know that there's, you have to add a, or and this would be A plus m. So we know that this has to be written as 2 plus m minus 1 over 2 because there's that many terms here, m minus 1 over 2. And for each term, obviously, we're adding 1 as we go along. So if there's m minus 1 over 2 terms after 2, then for sure the last term or the largest term needs to be m minus 1 over 2 greater than 2. Okay, so we follow similar logic for the sequence B, which is actually much easier because there's m minus 1 terms after 1. So all you do is 1 plus m minus 1 to get the largest term. And so it's 1 plus m minus 1 and then minus 99. And so now you just have to solve for m because they're asking for m. So this is obviously 101 is equal to m minus 1 divided by 2. This can be written as 2m minus m plus 1 over 2. 202 is equal to m plus 1. And so m is equal to 201. So the key to this question really is that to kind of recognize the symmetry that we have and the fact that what consecutive numbers means, because you don't need to worry about the common difference and introduce like a d variable. So that's a convenience of this problem. And that's how you can solve it, because if you introduce, so you want to try to reduce the number of variables that you introduce to in each question, because that just overcomplicates things. You could definitely have written this as a more complicated series, like start out with like this form and then go on from there, but you want to try to avoid that. So you recognize the symmetry, and I think that's one of the biggest keys in this problem. And considering that the middle term is equal to the average of the two, is something that you want to pay attention to, and I think this is a very important property to memorize.